in the binomial expansion of 2 raised to 1 by 3 plus 1 by 3 raised to 1 by 3 and this raised to n, where n is some natural number, if the ratio of 15th term from the beginning to 15th term from the end, this ratio is 1 by 6, right? So then we have to find the value of NC3. So basically, using this ratio, the ratio of 15th term from beginning to 15th term from end is given. This is 1 by 6. So from there, we need to find the value of n. And once we have n, then we need to calculate NC3. Now, before we attempt this problem, there is one simple concept here. If I need a particular term from end in a binomial expansion, so there are two ways of finding that one. One general method is that if I need rth term from end in the binomial expansion of a plus b raised to n, so if the exponent is n, the total number of terms that will be n plus 1. So if I need tr from end, then you can say that this will be t n minus r plus 2 from beginning. Right, this is the general method of finding a particular term from end. However, there is another much easier method where you don't have to deal with these terms. You can directly write a particular term from end. So basically the concept is that if I need a particular term from end in the expansion of a plus b raised to n, so then you can just interchange a and b. Right, so instead of writing a plus b raised to n, you will write b plus a raised to n. And then instead of finding the particular term from end, you will find the term from beginning. That means tr from end in a plus b raised to n. This will be same as tr from beginning in b plus a raised to n. So using this concept, in one line you can write a particular term from end. You don't have to worry that which term is this particular term from beginning, right? So we are going to use that concept here. It is given that T15 from beginning, right? T15 from beginning, and this divided by 15th term from end. So that means T15 from end, and this ratio is given as 1 by 6. Now we have a standard formula for finding a particular term from beginning. If I need T15 from beginning in this expansion, then it will be nothing but 15 NC14, right? The formula for general term is that if I need TR plus 1, maybe I'll write the general formula also. If I need TR plus 1 in A plus B raised to N, then this is NCR a raised to n minus r and then b raised to r. This is standard formula for finding a particular term from beginning. Tr plus 1 ncr a raised to n minus r b raised to r. So if I need 15th term from beginning, it will be nc14 and then first term. So that means 2 raised to 1 by 3. This raised to n minus 14. And then second term. So that means 1 by 3 raised to 1 by 3 and this raised to 14. This is 14th term from beginning in binomial expansion of this one. And similarly, sorry, 15th term. Similarly, if I need 15th term from end, so now we'll just interchange these two. Right now, first term will become 1 by 3 raised to 1 by 3, and this will become second term. So again, T15 from end, this will be NC14. And now the first term is this one, 1 by 3 raised to 1 by 3, and this raised to n minus 14, right? NCR, a raised to n minus r, b raised to r. So this will be a, and then b will be 2 raised to 1 by 3, and this raised to 14. And this ratio is given as 1 by 6. Now from here, we have to find the value of n. Once we have n, then we can calculate NC3 from there. So now let us simplify this one. Clearly you can see that NC14 will cancel, and then you have 2 raised to and n minus 14 minus 14. So that will become n minus 28 and this divided by 3. Right, n minus 14 minus another 14 and this is 2 raised to 1 by 3. So n minus 28 by 3. And similarly, here you will get this term will go in numerator. So that means you have 3 raised to, and again n minus 14 minus 14 from here. So that means n minus 28 and this divided by 3. And on right hand side, we have 6 raised to minus 1. Now for these two number, exponent is same, so you can basic exponent is same, so you can combine the base. That means this left hand side is 6 raised to this number. So now just equate the exponent and we'll get n minus 28 by 3. This equals to minus 1. So from here clearly you can see that n will be 25. Right, that will be the value of n. Now we needed NC3. So NC3, this will be nothing but 25C3. And 25C3, anyone can calculate. After calculation, you will find that this value is 2300. So therefore, the correct answer for this problem will be second option. Right. So in this problem, it was not difficult problem, and the important concept was that whenever we need a particular term from end in binomial expansion of a plus b raised to n, then just interchange a and b and then find the term from beginning. So tr from end in a plus b raised to n, this will be same as tr from beginning in b plus a raised to n. Also, there is another important point here, that while interchanging these two, you will take care of sign also. That means instead of a plus b, if I have a minus b, so then you cannot write this as b minus a, right? Then you will write minus b plus a. You have to change with sign. So if I have a minus b raised to n, and if you need a particular term from n, then you will write minus b plus a raised to n, and then you will find that particular term from beginning, right? So this you have to keep in mind. Now, by taking the ratio of 15th term from beginning, 15th term from end, we got the value of n as 25. We had to calculate NC3, that means we have to find 25C3, which is 2300, and therefore the correct answer for this problem is second option. Find the term independent of x. Term independent of x means constant term in the binomial expansion of this one. Now, this is a problem from JEE Main 2021, but the exactly same problem has been asked in JEE Main multiple times, most recently in JEE Main 2025. So, in this problem, first we need to simplify these two terms, right? And then after that, we have to see what should be the constant term in the binomial expansion of this raised to 10. So, first let us try to simplify this one. When in denominator, you can see that we have x raised to 2 by 3 minus x raised to 1 by 3 plus 1. So let us say x raised to 1 by 3, this is nothing but alpha. Let us replace x raised to 1 by 3 with alpha. So this first term, this will be alpha cube plus 1, right? If we take x raised to 1 by 3 as alpha, then x will be alpha cube. So numerator will be alpha cube plus 1. And in denominator, we have alpha square minus alpha plus 1. And now you can see that how to simplify this one. In numerator, we have a cube plus b cube. So that we can write as a plus b. And this multiplied by a square minus ab plus b square. Right? Alpha cube plus 1 cube. So we can use that formula of a cube plus b cube. And in denominator, we have alpha square minus alpha plus 1. So these two terms you can cancel, and then after that we have alpha plus 1. Alpha is x raised to 1 by 3, so this term will become x raised to 1 by 3 plus 1. After simplification we'll get this one. Similarly, second term is x minus 1 by this thing in denominator. So if I have to simplify that one, then you can take root x common in denominator, right? If you take in denominator we have x minus root over x. So if I take root x common, then you will get root x minus 1. And now this x in numerator, this you can write as root x minus 1, this multiplied by root over x plus 1. And in denominator, we have root over x into root over x minus 1. And now you can see that root x minus 1 will cancel. So basically we are left with root over x plus 1, that divided by root over x. And if you separate these two terms, then you will get x plus 1 by root x. So this is the second term, right? Now the given expression will be, we have to take difference of these two. So this was first term, this one is second term, and we have to do 1 minus 2. So 1 will cancel, and basically you will get x raised to 1 by 3 plus 1 by x raised to 1 by 2, and this raised to 10. And now we need constant term in the binomial expansion of this one. So now it becomes NCERT level problem. We have to write the general term and then equate the exponent of x to 0, because we need the coefficient of x raised to 0 or the constant term here. And then from there, find the value of r and then we can get the coefficient. So here the general term tr plus 1, this will be 10cr. In fact, here you will get one minus sign, right? We are taking difference of these two. So this will become x raised to 1 by 3 minus 1 by x, 1 by root over x. So general term will be 10cr and then x raised to 10 minus r by 3, right? X raised to 1 by 3 raised to 10 minus r. So x raised to 10 minus r by 3. And then this second term raised to r. So minus 1 raised to r and then x raised to minus r by 2. So this is the general term that we are getting, right? Now, if I need the constant term, then we have to equate the exponent of x to 0. And exponent of x will be 10 minus r by 3 minus r by 2. Right? If I combine these two exponents, so this is what we'll get. And after solving this, you will get r as, we can cross multiply. So 20 minus 2r, that will be 3r. 5r will be 20, that means r is 4. Right? So in this expansion, the fifth term will be independent of x. Right? When you expand it using binomial theorem, then you will get total 11 terms. And t5, because r is 4, so tr plus 1, that means t5, that will be independent of x. Right? So the constant term in the binomial expansion of this one is nothing but t5. And what will be t5? So x raised to 0 and coefficient will be 10c4 and this multiplied by minus 1 raised to r. So minus 1 raised to 4. Now 10c4 after calculation will give you 210 and minus 1 raised to even power is, any even power is plus 1. So therefore, in the binomial expansion of this one, the constant term or the term independent of x, this will be 10c4 or 210. So that is the correct answer for this problem, right? And if you see the PYQ, I mean, same question have been asked multiple times, right? So in this problem, the important concept was to simplify these two terms. First term after simplification was x raised to 1 by 3 plus 1. Similarly, this was the second term. And now when you do take difference of these two, then we are left with x raised to 1 by 3 minus 1 by root x raised to 10. Write the general term, equate the exponent of x to 0. We got r as 4. So that means term independent of x will be t5, and the value of that one is 210. So the correct answer for this problem is 210. Find the remainder when 428 raised to 2024 is divided by 21. Now in JEE Main, the problem on remainder calculation is very common, right? In last few years, you will find that there are number of PYQ where we have one number raised to some large power, and if we divide that number by some other number, then we have to figure out the remainder. Now here, generally for those problems, you'll find that this base is a small number, right? But here in base, we have 428. So the very first step will be that divide this 428 by 21 and see what is the remainder we are getting. So in that way, you can reduce the base here. So if you divide 428 by 21, clearly you can see that 420 will be multiple of 8. So that means 428 we can write this as 420 plus 8, and 420, this is multiple of 21. So let us say this number is n. So we can write n as 8 plus 420 and this raised to 2024, right? Now if I expand it using binomial, then you will get 8 raised to 2024, and after that all the subsequent terms, right? The second term will contain 420, the third term will contain 420 square, and so on. So only this first term, which is 8 raised to 2024, that is not multiple of 420. All the other subsequent terms, they are multiple of 420, and hence they are multiple of 21. So therefore, all of those numbers we can write as 21 into k, where k is some integer. And if you divide this number by 21, then you will get 0 as remainder, right? When you divide a number which is multiple of 21 by 21, then the remainder will be 0. So now this one we can neglect and we have to focus on this 8 raised to 2024. So now we need to see that which exponent of 8 is either 21 plus minus 1 or some multiple of 21 plus minus 1. That means if I do 8 square, right, we have to figure out different exponents of 8. So if I do 8 square, we'll get 64 and 64 is 1 plus 63. 63 is multiple of 21. So that means now we have to write this number 8 raised to 2024 as 8 square raised to 1012. 8 square will be 64. 64 is 1 plus 63. So now 1 plus 63 raised to 1012. And now you can see that if I expand it using binomial, then we'll get 1. The next term will be 1012C1, this multiplied by 63. After that, the next term will be 1012C2 and this multiplied by 63 square. So you can see that all of these terms, right, the last term will be 63 raised to 1012. We do not even have to, once you practice a Bayesian problem, you can directly see the answer. So now all of these numbers, right, except the first one, all the remaining numbers, they are multiple of 63 and 63 is multiple of 21. So that means all of these numbers we can combine and we can say that that is some multiple of 63 and hence multiple of 21. So therefore this number n, this will be of the form multiple of 21 plus 1, right? N is this number, n will be some multiple of 21 plus 1, and if I divide this number by 21, clearly the remainder will be 1. So that is the correct answer for this problem. Right, so in this problem, first step was that decrease this base, right, reduce this base 428. So for that, divide 428 by 21, you will get 8 as remainder. So that means we can write this number as 8 plus 420 raised to 2024. Expand it using binomial. Only this first term is not multiple of 21. All the other terms, they are multiple of 21. So we can neglect multiples of 21 because we are dividing by 21. And now we had to see that which power of 2 is either 21 plus minus 1 or some multiple of 21 plus minus 1. So 8 square is 64. 64 is 1 plus 63. So finally this number was multiple of 21 plus 1. And if you divide by 21, the remainder will be 1. Find the remainder if this number is divided by 17. Now in JEE Main, the problem on remainder calculation is very common, right? If you see the PYQ from last 4 or 5 years, you'll find a number of problems on remainder calculation, right? Now, generally when we are solving problems on remainder calculation, we have one number raised to some other exponent, and this base is a small number, right? But here if you see this example, we have 2021 raised to 3762, right? This is the number which is given. N is 2021 and this raised to 3762. Now here our aim will be first to decrease this base, right? First we have to, instead of 2021, we have to convert this into a smaller base, and from there we can see how to find the remainder. Now, in order to decrease this base, basically we'll divide 2021 by 17, right? We'll divide this number by 17. Now, when you divide by 17, you'll find that this number will become 17 into 118 plus 15, right? When you divide by 17, you'll get remainder as 15. So, one way of writing 2021 will be 17 into 118 plus 15. Another approach will be that you can write the same number as 17 into 119 minus 2. Now, we should always prefer the second form. Why? Because in this form, we are dealing with a smaller base, right? If you convert 2021 in this second form and apply binomial expansion, so then at the second stage, you are dealing with minus 2 raised to something. Whereas in first form, we'll get 15 raised to something. So obviously, we have to prefer the second one instead of first one. So we can write this number as minus 2. We'll write in terms of increasing power of multiples of 17. So we'll write this as minus 2 into, and let us call this as 17 into some integer, 17k. So minus 2 plus 17k, and this raised to 3762. Now when I expand this number using binomial theorem, then the very first term will be minus 2 raised to this number, and because this is even, so we'll get plus sign. So 2 raised to 3762. And after that, only the first term will not contain 17. After that, in the second term, we'll have 17k. Next term will be 17k square and so on. So all of those numbers, they are multiple of 17. Right, only the first term is not multiple of 17. After that, all the subsequent terms, they are multiple of 17. And when you divide this term by 17, the remainder will be 0. So now basically we have to focus on this number 2 raised to 3762. Now again, here we have to see that which exponent of 2 is either 17 plus minus 1 or multiple of 17 plus minus 1. So clearly you can see that 2 raised to 4, this will be 16, and 16 one can write as minus 1 plus 17. Aim is to write multiple of 17 plus 1 or minus 1, or multiple of 17 plus 1 minus 1. So here basically we'll try to write this number as 2 raised to 4, because we want to create 17 here. So 2 raised to 4, and then 3762. 3760 will be multiple of 4, and in fact you will get 940, and this multiplied by 2 square, right? Because this number is not perfectly divisible by 4, so we have taken 2 squares, we have separated 2 square, and then 3760, that will be 4 into 940. And now we have 2 raised to 4, which is minus 1 plus 17. Right, 2 raised to 4 will be 16, so that is minus 1 plus 17, that multiplied by, that raised to 940, and this multiplied by 4. 4 we can keep separate. Minus 1 raised to even power, so that will be plus 1. And again, after that, all the subsequent terms, right, the second term will be minus 9c 940c1, this multiplied by 17. After this, next one will be 940c2, and this multiplied by 17 square, and so on. So only this first term is not multiple of 17. After that, all the other subsequent terms, they are multiple of 17. So basically this number n, this will become 4 into 1, that is 4. And then all these numbers will contain at least 117, right? 17, 17 square, and so on. So all of them are multiple of 17. That multiplied by 4 is still multiple of 17. So basically that given number is of this form, right? Number n, this will be some multiple of 17 plus 4. And when you divide this number by 17, the remainder will be 4. So that is the correct answer for this problem. Right, so in this problem, first important concept, that we need to decrease this base, and for decreasing the base, we'll always prefer this second form, because then we are dealing with 2 raised to something. But if we write this in first form, then we'll get 15 raised to this number, right? So obviously, we'll have much easier calculation if I have a smaller base. And then once we have 2 raised to something, 2 raised to 4 is 16, 16 is minus 1 plus 17. And after that, apply binomial theorem. Finally, the number is multiple of 17 plus 4. When you divide by 17, remainder will be 4. And that is the correct answer for this problem. Find the remainder when 2021 raised to 2023 is divided by 7. Now, in this problem, the first step will be to reduce this base. Right? Let us say that this number is n is 2021, and this raised to 2023. Now, first we have to divide 2021 by 7, and then see what is the remainder we are getting. How we can reduce this base. So when you divide 2021 by 7, you will get 7 into 288 plus 5. Right, this is one way in which you can write 2021 as multiple of 7 plus some remainder. Another approach will be that you can write the same thing as 7 into 289 minus 2. Right, now when we have to reduce this base, when we have to decrease this base, then we should always prefer the second form. Why? Because in this case, we are dealing with a smaller number minus 2. right? This number 2021, this we can write as minus 2, and this one you can say this is some multiple of 7. So minus 2 plus multiple of 7, this raised to 2023. And you can see that if I use binomial theorem here, then you will get minus 2 raised to 2023, and after that all the other terms will contain 7m raised to 1, 7m raised to 2, and so on. So only the first term is not multiple of 7. After that all the other terms, they are some multiple of 7, right? In second term you will have 7m, then next term will be 7m square. So all of them, they are multiple of 7, and if you divide those numbers by 7, the remainder will be 0. So now basically we have to focus on this number minus 2 raised to 2023, right? But you can see that if I write in this first form, then here you will get 5 raised to something, and then we are dealing with a bigger number, right? Our aim is always to have a smaller base so that the calculation will not be that complicated. Now because we are dividing by 7, we have to see that which exponent of 2 is 7 plus minus 1 or multiple of 7 plus minus 1. So clearly again you can see that 2 cube will be 8, and 8 is 1 plus 7. So here we'll try to write this number as minus sign we can keep common, and then we can write this as 2 cube raised to something, right? So you can see that 2 raised, 2022, that will be multiple of 3. So you can separate 1, 2, and 2022, if you divide by 3, then you will get 6, and then you have 7 and 4. So we can write the same number in this form, right? The second part, multiple of 7, remainder will be 0, and now this is the number that we are getting. Minus 2 you can keep outside, and then you have 1 plus 7, right? 2q will be 8, 8 is 1 plus 7, so 1 plus 7, this raised to 674. Now again when you expand this one, you will get minus 2, and you have 1 plus, and the second term will contain 7, next term will contain 7 square. So again all of them, they will be multiple of 7 only, right? Now when you multiply these numbers, finally you will get multiple of 2 into multiple of 7 is multiple of 7, right? And then 1 into minus 2, that is minus 2. So this is the number, right? That given number will be of the form multiple of 7 minus 2. And when you divide this number by 7, then the remainder will be minus 2 plus 7, right? Whenever you get negative remainder, that means we have over divided. So we have to, if we are dividing by 7 and the remainder we are getting is minus 2. So then when 7m minus 2 is same as 7m plus 5, right? So when we divide this number by 7, the remainder will be 5, and that will be the correct answer for this problem. So, in JEE Main, there are multiple PYQs on remainder calculation, and this is one important concept that if I have to write 2021, so instead of writing in first form, write in second form, because then we are dealing with 2 raised to something, right? And then because we are dividing by 7, we have written this as 2 cube raised to something. 2 cube is 8, 8 is 1 plus 7. And finally, the number was multiple of 7 minus 2. So if you divide a number of this form by 7, the remainder will be 5. And that is the correct answer for this problem. Find the remainder when this number is divided by 50. Now, as you can see that these numbers which are given, they are in GP, right? We have 1, then we have 3, 3 square, and in this manner, we have up to 3 raised to 2021. So first let us calculate the sum of these in terms of GP using this standard formula, that in GP, sum of n terms is a into r raised to n minus 1, where a is the first term and r is the common ratio, and this divided by r minus 1. So first let us find this number, and then we'll see that how to figure out the remainder when this number is divided by 50. So here if I calculate sum of all these, let us say that number is n. So this n will be a is 1, and then r is 3. So we'll get, also in denominator we'll get r minus 1. So r minus 1 means common ratio is 3. So we'll get 3 minus 1, that is 2. And 3 raised to number of terms. Now first term is 3 raised to 0, last term is 3 raised to 2021. So starting from 0 up to 2021, the total number of term will be 2022. So basically this is the term, right? N is 1 by 2 and this is the number 1 by 2, this multiplied by 3 raised to 2022 minus 1. And now we are dividing this number by 50. So we have to find the remainder. Now see here what we can do is, uh, we can, instead of trying to find remainder when the number is divided by 50, let us try to write this number as multiple of 100, right? And then from there we can see that what should be the remainder if we divide by 50, because 100 will be a perfect square and we can very easily create multiples of 100 here, right? You can write this number n as half of, and then if I have to create multiple of 100, then this number we can write as 3 square raised to something, right? And 3 square will get 9. 9 we can write as 10 minus 1, right? So 3 raised to 2022, this we can write as 3 square raised to 1011. 3 square is 9, which is minus 1 plus 10. So minus 1 plus 10, this raised to 1011 minus 1, right? And now let us apply binomial theorem on this one. So if I apply binomial theorem, we'll get minus 1. The next term will be 1011 C1 and this multiplied by 10. Right, the first term raised to odd power, so we'll get negative sign. Second term will be positive. And after that, the third term will contain 10 square. 10 square means we have multiple of 100. Right, so after that, all the other terms we can write as multiple of 100. Right, so basically this is the number that we are getting. If I further simplify this one, we'll get 10110 and then plus multiple of 100 minus 2, right? When we are expanding in terms of exponent of increasing powers of 10, so only the first two term they are not multiple of 100. After that, the third term will be 10 square, fourth term will be 10 cube, and so on. So all of those numbers they are multiple of 100. And because we have 1 by 2 outside, so when we can easily figure out what should be the remainder when we are dividing by 50. So now we can write this number as 1 by 2. And from here also, if you want, you can separate multiples of 100. That means this number you can write as 10,000 plus 110. Right? In fact, we can write this as 10100 and 10 minus 2, that will be 8 plus multiples of 100. And now this is also multiple of 100. So we can combine these two. And finally, the number is of this form, right? If you divide by 2, so 8 by 2, that will become 4. And these two numbers you can again combine, right? You can take 100 common and then you have lambda plus 101. Lambda is just some positive integer, right? Lambda is any positive integer here, some natural number. So lambda plus 101, that will be another natural number. So basically these two terms, they are multiple of 100, and when you divide by 2 you will get multiple of 50. So this becomes 50 lambda, and 4 by 8 by 2, that will be 4. So finally the number is of this form, multiple of 50 plus 4. And now if you divide this number by 50, clearly you can see that remainder will be 4. So this was a very interesting problem where first we had to identify the number using this formula of sum of n terms of ZP. So a into r raised to n minus 1 by r minus 1. And now because we are dividing by 50, so we have tried to create multiples of 100, right? So for that, 3 raised to 2022, this we can write as 3 square raised to 1011. And now expand it using binomial theorem. And we'll write the first two terms, right? First term is not multiple of 100. Second term is also not multiple of 100. After that, all the other terms, they are multiple of 100 because they will contain 10 square, 10 cube, and so on. And now this number also you can simplify. You can separate 10110 from there. So finally you are left with 10 minus 2, which is 8. 8 by 2, 4. And rest of the numbers, they were multiple of 100. But when divided by 2, they became multiple of 50. So the number was multiple of 50 plus 4. When you divide by 50, the remainder will be 4. And that is the correct answer for this problem. Find the remainder when 19 raised to 200 plus 49 raised plus 23 raised to 200 is divided by 49. Now, before we attempt this problem, there are few important observations. the very first thing is that 49 is a perfect square, right? 49 will be 7 square. Also, you can notice that for these two numbers, we have same exponent 200. One number is 19 raised to 200, other number is 23 raised to 200. So for these type of problem, what we'll do is that we'll try to break this symmetrically, right? We'll try to break 19 and 23 symmetrically about some multiple of 21, right? Between 19 and 23, we have 21, and 21 is multiple of 7. So 19 we can write as minus 2 plus 21, this raised to 200. And 23 you can write as 2 plus 21, and this raised to 200. Because we have same exponent, we are dividing by 49, which is 7 square. 21 is multiple of 7. So here we can break 19 and 23 symmetrically about 21. We can write 19 as 21 minus 2 and 23 as 21 plus 2. Also, I'm trying to write this is expansion in increasing powers of 21. Right, so therefore first I have written minus 2 and then 21. Now you can see that if I expand it using binomial theorem, then in this first expansion, you will get alternate positive and negative terms. In the second one, you will get all positive terms. And the negative term of this first one, that will be cancelled by the positive term of this second expansion. So basically the expansion will be twice of, and this first term you will get twice. Second term will cancel because it will have same magnitude. But in this first one, you will get minus sign. In second one, you will get plus sign. And similarly, T3 you will get twice, T4 will again cancel. So the expansion will be 2 into, right, all that positive terms you will get twice and negative term will cancel. So we'll get 2 into 2 raised to 200. 200 C1 term will cancel. So next one will be 200 C2. And this multiplied by minus 2 raised to even power 198. That is 2 raised to 198. And then 21 square. Again 200 C3 term will cancel, and after that you will get 200 C4, 2 raised to 196, 21 raised to 4. Now we are dividing this number by 49. 49 is 7 square. In 21 square, we have 3 square into 7 square. So that means this term is multiple of 21 square, and hence it is multiple of 7 square. After that, next term will be 21 raised to 4. That is also multiple of 7 square. So in fact, except for this first term, all the other subsequent terms, they will be multiple of 49. So you can combine all of these terms and you can say that this will become 2 into and then 200 plus another one, so 201 plus some multiple of 49, right? All of these terms, they are multiple of 49 multiplied by 2, they are still multiple of 49. And if you divide the multiple of 49 by 49, the remainder will be 0. So from this term, you will not get any remainder. So now basically we have to focus on 2 raised to 201. And again, we have to think that which power of 2 is 7 plus minus 1 or multiple of 7 plus minus 1, because we are dividing by 49 and 49 is 7 square. So clearly you can see that 2 cube will be 8 and 8 we can write as 1 plus 7. So therefore we'll write this as 2 raised to 3 and this raised to 67. 201 is multiple of 3. 3 into 67 will be 201. So now we'll get 2 cube, this we can write as 1 plus 7 and this raised to 67. Expand it using binomial and we have 1 plus 67 C1 into 7. Next term will be 67 C2 into 7 square. After that, all the other subsequent terms and the last term will be 7 raised to 67. So except for the first two terms, all the other terms, they are multiple of 7 square and hence multiple of 49. Right, 7 square, next one will be 7 cube and so on. So all of these numbers, they are multiple of 49, right? So if I divide this one by 49, the remainder will be 0. So basically we are left with this number. The number n will be 1 plus, and then we have 67 into 7 plus some multiple of 49. When divided by 49, they will give us 0 remainder. Now here again you can see that, I mean, in this number we can manually calculate the remainder, multiply these two numbers and then see what is the remainder when we are dividing by 49. But if you want, you can save some time in calculation. 67 you can write as 49 plus 18 and this multiplied by 7, and again 49 into 7, that is multiple of 49, so that you can neglect. So basically we are left with 18 into 7 plus 1. Now 18 into 7 will be 126 plus 1, so that will be 127, right? So basically this number is 127 plus some multiple of 127 plus some multiple of 49. Ultimately the number is of this form. And now just find the remainder in 127 when we are dividing that number by 49. So clearly you can see that if you divide 127 by 49, you will get 98. So 2 and another 27. So that is 29. So if you divide 127 by 49, the remainder will be 29. So that is the correct answer for this problem, right? So I mean, this was a very interesting problem where first we had to break this number symmetrically about 21, because 21 was 3 into 7 and 49 is 7 square. After that, when you expand it using binomial, only this first term is not multiple of 49. All the other terms, they are multiple of 21 square and hence multiple of 49. Now again, this 2 raised to 201, this you can write as 1 plus 7 raised to 67. Expand it using binomial, and now first two terms, they are not multiple of 49. All other terms, they are multiple of 49. So finally we got 127 plus multiple of 49. When you divide 127 by 49, the remainder will be 29. And that is the correct answer for this problem. Find the remainder when 2023 raised to 2023 is divided by 35. Now, generally we solve these type of problem using binomial theorem, but for this particular problem, there is another interesting approach of attempting this problem. So we'll discuss that another method of solving this problem. First of all, 35 is 5 into 7, and 2023, this is multiple of 7, right? So let us say this number is n. So we can write this number n as 2023 and this multiplied by 2023 raised to 2022. Why I am separating 12023? Because this is multiple of 7. In fact, you can write this number as 7 into, and then we have 289, and this multiplied by 2023 raised to 2022, right? Now our aim will be to write this number as multiple of 5 plus something, right? 7 we already have outside, and if I can write the rest of this number as multiple of 5 plus some number lambda, where lambda can take any values between 0 and 4, right? Lambda will be either 0 or 1 or 2 or 3 or 4, because if we are dividing a number by 5, then you can have remainder between 0 and 4. So our aim will be to write this number 289 into 2023 raised to 2022. And because we already have one 7 outside, in next step you can see that this will become 7 into 5, that is 35m plus 7 lambda. And 35 into m is obviously multiple of 35. So from here we can get the remainder. So now basically the problem becomes that what is the remainder when this number, let us call that number n1. So now the problem becomes that we have to find the remainder when 289 and this multiplied by 2023 raised to 2022, this is divided by 5. We have to write this number as multiple of 5 plus some remainder, so that in next step we can get the remainder when the number is divided by 35. Now in order to find the remainder when a number is divided by 5, we have to find the digit at unit place of that number. If I can get the digit at unit place of this number n1, then we can easily see what will be the remainder when we divide this number by 5. Also, for finding the digit at unit place, only the unit digit is significant, right? For example, that means that digit at unit place of this number 2023 raised to 2022 will be same as the digit at unit place of this number 3 raised to 2022. All the other numbers, they are irrelevant when we are calculating the digit at unit place. And for finding the digit at unit place of this number 3 raised to 2022, we can use cyclicity. That means if you see the digit at unit place in different exponents of 3, 3 raised to 1 is 3. For 3 square, the digit at unit place will be 9. For 3 cube, the digit at unit place will be 7. For 3 raised to 4, the digit at unit place will be 1. And once you get 1, you will get the same pattern again. That means the digit at unit place in different exponents of 3 will be 3971. Again, you will get 3971 and so on. So whenever the exponent of 3 is multiple of 4, the digit at unit place will be 1. That means 3 raised to 4, 3 raised to 8, 3 raised to 12 and so on. At unit place, you will get 1. Whenever the exponent is multiple of 4 plus 1, that means 3 raised to 1 or 3 raised to 5 or 3 raised to 9 and so on, the digit at unit place will be 3. Similarly, whenever the exponent is multiple of 4 plus 2, the digit at unit place will be 9. Here this number 2022, this is nothing but multiple of 4 plus 2, right? 2022 you can write as 2020 plus 2. So the exponent of 3, this is multiple of 4 plus 2, and whenever the exponent of 3 is multiple of 4 plus 2, the digit at unit place will be 9. So basically in this number 2023 raised to 2022, the digit at unit place will be 9. That 9 multiplied with 289 will give us 1 at unit place. So that means in this number n1, the unit digit will be 1. And if we divide this number by 5, then what should be the remainder? If we have 1 at unit place, and if we divide that number by 5, the remainder will be 1, right? So this number 289 into 2023 raised to 2022, that you can write as multiple of 5 plus 1. And that means this number n will be 5m into 7, so that is 35m plus 7. So finally the number n is of this form. The number n will be multiple of 5 plus 7. And if you divide this number, number n will be multiple of 35 plus 7. And if you divide this number by 35, the remainder must be 7. So that is the correct answer for this problem. Right, so you can see that without using binomial theorem, simply by using the cyclicity, we got the remainder in this problem. First observation, this number 2023, this was multiple of 7, and 35 is 5 into 7. So we have taken one 7 common, and then we have written rest of the numbers as multiple of 5 plus something. When we divided that number by 5, because we had 1 at unit place, we got 1 as remainder. So therefore this number will be 5m plus 1. Finally the number n will be multiple of 5, multiple of 35 plus 7. When you divide by 35, remainder will be 7. And that is the correct answer for this problem. We have this number n equals to 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190. And we have to check whether it is divisible by 14 and whether it is divisible by 34. Now, before we attempt this problem, there is one important concept that we have to learn, because here you can see that for all of these numbers, we have same exponent 190, right? So whenever you have same exponent, then you can use the following concept that we are going to discuss. In fact, there are two concepts. So the very first one is that if I have a raised to n minus b raised to n, where n is some natural number, some positive integer. So this is always multiple of a minus b, right? A raised to n minus b raised to n. This is always multiple of n, multiple of a minus b. N is any natural number. And if n is even number, then this is multiple of a plus b also. And using factor theorem, one can easily prove this result also. So if n is even number, then it will be multiple of a plus b. So a raised to n minus b raised to n, that is always multiple of a minus b. That means a square minus b square or a cube minus b cube and so on. They will always have this factor a minus b. And if the exponent is even number, for example, a square minus b square or a raised to 4 minus b raised to 4. So all of them, they are multiple of a plus b also. And there is another related concept, although not useful in this problem, but in some other problem you can apply, that if I have a raised to n plus b raised to n, so in that case, this will be multiple of a plus b. right? This is multiple of a plus b if n is any odd natural number, right? So for example, if I have a cube plus b cube or a raised to 5 plus b raised to 5, so then it is always multiple of a plus b. So these are the three things that you should know. Now we can proceed with this problem. The given number is 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190. And you can see that for all of these numbers, we have same exponent. And we have to find whether it is divisible by 14 or 34 or both of them. Now here, first of all, you can very easily check that whether this number is odd number or even number, right? Because then if I have to check whether a number is multiple of 14 or not, so a number will be multiple of 14 if it is multiple of 2 as well as multiple of 7. Similarly, it will be multiple of 34 if it is multiple of 2 and multiple of 17. So here 25 raised to 190, this will be odd number. 19 raised to 190, another odd number. Odd minus odd will be even. And the other two numbers, they are even number. So that means this given number n, this is even number. And once we have established that it is even number, now we do not have to check for 34 and 14. We need to check for 7 and 17, right? So first we'll check whether this number is multiple of 17, and then we'll check whether it is multiple of 7, because it will be multiple of 34 if it is multiple of 17 as well as multiple of 2. We have already established that even number is even number. Now, in order to check, in order to show that it will be multiple of 17, we can use this first result, a raised to n minus b raised to n. This is always multiple of a minus b. So here let us try to create 17. For that you can combine 25 and 8, right? 25 minus 8, that will be 17. So 25 raised to 190 minus 8 raised to 190. And you can combine the other two terms. That means 19 raised to 190 minus 2 raised to 190. Now clearly you can see that this first term, this is multiple of 17. This will be multiple of 25 minus 8, that is 17. Similarly, the second number, this is also multiple of 17, and therefore their difference is also multiple of 17, right? So this number n is multiple of 17 as well as it is even number. So it must be multiple of 34. That means option B is incorrect. 14 but not 34. This is also incorrect. Now we need to now we have to check for 14. And because we have already established that it is even number, so we need to check for 7. Right, so second part of this problem will be we need to check whether this number is multiple of 7 or not, right? Now, for that one, let us see that if we divide this number by 7, then what is the remainder we are getting? Also, we can combine some of these terms and see which of the above results are applicable here. So 25 and 8, that will give us 17. 25 and 19, if I take difference of those two, we'll get 6. 2 and 8, that will also give us 6, but we need 7. So maybe we can combine these terms. We can write 25 raised to 190 minus 8 raised to 190, and 19 and 2. If you combine these two, 19 and 2, so their sum will be 21. And a raised to n minus b raised to n, this is multiple of a plus b also, if n is even number. So clearly we have even exponent. So if I combine these two terms, 19 raised to 190 minus 2 raised to 190, so then we can show that this will be multiple of 19 plus 2, which means multiple of 21. And if it is multiple of 21, it has to be multiple of 7 also. So we can neglect this part, right? When we divide this one by 7, remainder will be 0. So now we need to focus on this number only. We have to see what will be the remainder when you divide this number by 7. So for that, 25 you can write as 4 plus 21 raised to 190, and 8 you can write as 1 plus 7 raised to 190. And now use binomial theorem. So it becomes 4 raised to 190. All the remaining numbers, they will be multiple of 7. So you can again neglect that one, and then minus 1 raised to 190, right? This we can write in this form. And now we have to see that which power of 2, right, which exponent of 2 is multiple of 7 plus 1 or minus 1. So for that we can do 4 cube. 4 cube will be 64. 64 is 1 plus 63, and 63 is multiple of 7. I'm not writing multiples of 7 here. I mean, the next term will be 190 C1 into 7. After that, 7 square and so on. Similarly, here also 21, 21 square and so on. All of them, they are multiple of 7. So we can neglect that part. Now, this one you can write as 4 into and 4 cube raised to 189 divided by 3. So that will be 63. And 4 cube is 64. 64 is 1 plus 63. So 1 plus 63 raised to 63 minus 1. And now clearly you can see that when you expand it using binomial, you will get 1 plus and then multiples of 63, which are also multiple of 7 minus 1. So finally this number n, this will be of the form 4 into 7m. So it is multiple of 7, and 4 minus 1, that will give us 3. And when you divide this number by 7, the remainder will be 3, which means the number is not divisible by 7 and therefore not divisible by 14, right? So the correct answer will be that this number is divisible by 34 but not divisible by 14. This should be the right answer, right? So you can see that whenever you have the same exponent, different terms are there and the exponent is same, then you can use these three results. A raised to n minus b raised to n, always multiple of a minus b, and if n is even, then multiple of a plus b. And a raised to n plus b raised to n, this is multiple of a plus b if n is odd natural number. So from there directly you can see that this number was multiple of 17, and for 7 we had to use binomial theorem, right? We had to, I mean, for this part we can directly claim that it will be multiple of 7, but for the other two terms using binomial we established that when you divide that number by 7, the remainder will be 3, and hence it is not multiple of 7. So the correct answer for this problem will be option D. Find the product of last two digits of this number 1919 raised to 1919. Now, in JEE Main, there are few PYQ where you need the digit at unit place or the digit at 10th place of a raised to b, where a and b, those are two integers. So in these type of problem, basically we have to create zeros here, right? We can write this, the given number is 19 raised to 1919. Now, this you can write as minus 1 plus 1920 raised to 1919. And then using binomial, you can easily find the digit at unit place or the digit at 10th place and so on. Also, sometimes the problem will be find the digit at unit place only. So in that case, you can use cyclicity also, right? If I need only the digit at unit place, then without using binomial also you can answer that. First of all, digit at unit place will be decided by this 9 only. The other digits, they are irrelevant. And if you see the different exponents of 9, so 9 raised to 1 will be 9. For 9 squared, the digit at unit place will be 1. For 9 cube, the digit at unit place is 9. 9 raised to 4, the digit at unit place is again 1, and so on. So for 9, this is the pattern you are getting 9, 1, 9, 1, and so on. Whenever exponent is even number, the digit at unit place will be 1. Whenever the exponent is odd number, the digit at unit place will be 9. So that means in this number, the digit at unit place, because the exponent is an odd number, the digit at unit place will be 9, right? So at unit place, we have to get 9. But because the problem is we need the last two digits, in fact, product of last two digits. If options were there, then only those options which are multiple of 9, that should be the valid option, right? But here, because it was integer type, so we have to use binomial. And then we have to see what should be the digit at 10th place. At unit place, we'll definitely get 9 because the exponent is odd number. Now here if I expand it using binomial, then minus 1 raised to odd power, that will be minus 1. Next term will be 19c, 1919c1, and this multiplied by 1920. After that, again, next term will have minus sign. right? Because of the negative sign, we'll get alternate positive negative terms and so on. First term was negative because we had -1 raised to odd power. Next will be positive, again negative, and so on. Now in next time you can see that you will get a square of this one, 1920 square, and in 1920 we have 1 0, so its square will have 2 zeros, right? That means the next number is definitely multiple of 100, right? After that, next number will have cube of this one, so that will be 100 into some integer. So you can combine all of those numbers and you can say that all the numbers after all the terms after the second term, they are multiples of 100. Now we do not, because if the number is multiple of 100, then it will not contribute to the digit at unit place or the tenth place, right? So therefore, we can combine all of those numbers and we can say that it is some multiple of 100, because we are interested in only the last two digits. So we can write rest of the numbers in this form. And now we have -1 plus 1919, and this multiplied by 1920 plus 100k. Now here also, if you want, you can save some time and you can write this number as uh, maybe 100k we can write first, and then this number you can write as 1900 plus 19, right? And the other number you can write as 1900 plus 20 and then -1. Why we are writing in this form? Because when you multiply these two, you will get four terms, and only 19 into 20, this is not multiple of 100. All the other numbers, they will be multiple of 100, right? So in fact, you can combine this one and you can say that we have 100k and all of these numbers, for example 1900 into 1900, so that is multiple of 100. 1900 into 20, that is also multiple of 100. So all of these numbers, that will be multiple of 100. 19 into 20 will be 380, and 380 minus 1, so we have 389. Now again, this 3 you can adjust with 100k, so finally the number is of this form, right? Finally the number n, this will be some multiple of 100, and the last two digits, in fact, will get 80 minus 1, so this will be 79, right? Multiple of 100, and then 380 minus 1, so that is 70, 379. 300 we can write with multiple of 100. So finally, this is the number, some multiple of 100 plus 79. So the digit at unit place is definitely 9, that we had seen earlier, we had established earlier also. And at 10th place, we are going to get 7. Now the problem is we need the product of digit at unit place and 10th place. So 9 into 7, 63. That is the correct answer for this problem. So in this type of problem, all we have to do is break this number as -1 plus 1920 and then use binomial theorem. All of these numbers, they are multiple of 100 and therefore they will not contribute to the digit at unit place or 10th place. Finally, the number was multiple of 100 plus 79. So at unit place we have 9, at 10th place we have 7. The product of last two digits, that will be 63, and that is the correct answer for this problem. If the coefficient of a raised to 7, b raised to 8 in the multinomial expansion of a plus 2b plus 4ab raised to 10 is k into 2 raised to 16, then we have to find the value of k. Now, the most common method of solving this problem is to use general multinomial theorem. However, one simple trick, and you can solve this problem within few seconds, right? Here, instead of using that general multinomial theorem, what we can do is, we need coefficient of a raised to 7 and b raised to 8. So from these three terms, we can take AB common, right? If you take AB, we need coefficient of a raised to 8, b raised to 7 in this one. Now just take AB common from here. And then we have, if you take a common from AB, you will get 1 by b. Similarly, if you take a common from this one, AB common from the second term, you will get 2 by a and plus 4 and this raised to 10. So that means we need coefficient of a raised to 7, b raised to 8 n, and now a raised to 10, b raised to 10, and this multiplied by, we have 2 by a plus 1 by b plus 4, this raised to 10. Now in the next step, you can see what we have to do. If I need a raised to 7 and we already have a raised to 10, so that means in this one we need 1 by a cube, right? 1 by a cube multiplied with a raised to 10 will give us a raised to 7. And similarly, if I need b raised to 8 and we already have b raised to 10, so in this expansion we need 1 by b square. So basically in the next line you can write that we need coefficient of 1 by a cube and coefficient of 1 by a cube into 1 by b square, because we have to create b raised to 8. We already got b raised to 10 here. So in this multinomial, we need 1 by b square. Similarly, we need a raised to 7. We already got a raised to 10. So in this multinomial, we need multinomial expansion of this one. We need 1 by a cube. So that means we need coefficient of 1 by a cube into 1 by b square in the expansion of 2 by a plus 1 by b plus 4, this raised to 10. And now think of 1 by a as alpha, 1 by b as beta. So basically the problem is we need coefficient of alpha cube beta square in 2 alpha plus beta plus 4, this raised to 10. And now you can very easily see what should be that coefficient. We have to distribute this exponent among these three terms. And if I need alpha cube, the exponent of this one must be 3. Right, if I need alpha cube, then exponent of 2 alpha must be 3. Similarly, if I need beta square, then exponent of beta, this must be 2. And total we have 10. If exponent of these two terms are 3 and 2, then exponent of 4 must be 5. Right. So now it is given that coefficient of this term is k into 2 raised to 16. And from here you can see that coefficient of that particular term, that will be 10 factorial, and this divided by 3 factorial, 2 factorial, 5 factorial, and then 2 alpha raised to 3 alpha cube, coefficient part will be 2 cube. Similarly, beta square, so coefficient will be 1 square, which is 1, and then 4 raised to 5, and this thing is given as k into 2 raised to 16. And now all we have to do is we need to simplify this one, and from there we have to find the value of k. So you can do the calculation part on your own. Once you simplify this one, after calculation, you will get k as 315. Calculation is not difficult to do. 10 factorial you can write as 10, 9, 8. 5 factorial you can cancel, and then rest of the calculation you can perform. Also, this will become 2 raised to 13, right? So from there, finally you will get k as 315. So the correct answer for this problem will be, we needed value of k is 315. So you can see that one simple trick, just take AB common from here, and then how easily we can directly solve this problem, right? Obviously we need to know multinomial theorem for that one, but now you can directly see what should be exponent of these three terms, alpha, beta, and the constant term, right? Because once you take this one common, and if I need a raised to 7, we got a raised to 10 here, so that means we need 1 by a cube. Similarly, 1 by b square. So we need to distribute this exponent in this manner, 3, 2, and 5. So finally, after calculation, you will get k as 315, and that is the correct answer for this problem. If sum of this series 40C0 plus 41C1 plus 42C2 and so on to 60C20, this is m by n into 60C20, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The HCF of m and n will be 1. So then we have to find the value of m plus n. I mean, whenever you have one integer divided upon another integer and we have to find m plus n, we need to find unique value of m and n. So then this condition is added that m and n, these two are co-prime number. So therefore there is no common factor between those two. If there is any common factor, you have to cancel that one and write this fraction in a smallest form. So here first we need to simplify this left hand side, and then we'll compare with this right hand side, and we'll see what should be the value of m and n. Now, before we attempt this problem, there is one important property of binomial coefficient that we must know. The property is that if I have when CR, plus ncr plus 1, then this is nothing but n plus 1 cr plus 1. Right? This is one very important result related with binomial coefficients, that ncr plus ncr plus 1. This is n plus 1 cr plus 1. In order to apply this property, you can see that these two must be same, and here there should be difference of 1. If one term is r, other one should be r plus 1. So then we need to add 1 in this one. So this becomes n plus 1 and then cr plus 1. Now, in these type of problem where you have sum of binomial coefficients and this thing is changing C0, then C1, C2 up to C20. So then you can think of this property. See here, 40C0, next term is, let us write the left hand side. Left hand side is 40C0 plus 41C1 plus 42C2. I'll write few more terms. Next will be 43C3. And in this manner, it will continue up to 60C20. Now, in order to apply this property, as I said earlier, that these two numbers must be same, n and n. Right now, one is 40C0, other one is 40. Here we have difference of 1. One is C0, other one is C1. But these two must be same, then only we can apply this property. So for that, we are going to use one interesting trick, that 40C0, this will be same as 41C0. Right, 40C0 or 41C0, those two are same, and their value will be 1. Right, NC0, whatever be the value of n, is always 1. So instead of 40C0, I'm writing 41C0. And now you can combine the first two terms. Right, you can see that if we combine these two terms, then sum of these two terms, one is NCR plus other one is NCR plus 1. So this will become n plus 1 cr plus 1. That means sum of these two, this will be nothing but n plus 1. So from 41 you will get 42 and then c1. Now you can see what will happen if I combine it with the next term. Right, now if I combine the first three terms, sum of first two term is 42c1. Now add 42c1 with the next one. Right, so 42c1 plus 42c2, this will become 43c3. Now add sum of first three term, this is 43c3, c2 in fact. Right, we have to add 1 and then we have to take the bigger number here. So 42c1 plus 42c2, this will be 43c2, and 43c2 added with this next one. Right, now we are going to add the first four terms. Sum of first three term is 43c2. 43c2 plus 43c3, this will become 44c3. Right, so you can see that you can add this term with the next one and you can use this property. So ultimately, when you add all the terms on left hand side, you can see that 43 became 44, c3 is same as c3, 42 became 43. So you can see that if I continue this operation till the last term, then this 60, this will become 61 c20. Right, you can see that this number is not changing. If I add the first four terms, then the result is 44c3. So if I add all of these terms, the result will be 61c20. So that is the sum of left hand side. Right, the left hand side will be 61c20. And now on right hand side, we have m by n, this multiplied by 60c20. And now we have to use the definition of NCR. So 61c20, this is 61 factorial, and this divided by 61 factorial, and that divided by 20 factorial, multiplied by 60 minus 20, that is 41 factorial. And on right hand side, we have m by n, and then this will become 60 factorial divided by 20 factorial into 40 factorial. So from here clearly you can see that m by n, this will become 20 factorial, you can cancel 41 and 40. So you will get 41 factorial in denominator, right? 41 factorial you can write as 41 into 40 factorial. So and similarly 60 and 61. So you will get 61 there. So that means m by n, this is 61 and that divided by 41. And as you can see that there is no common factor between 61 and 41. In fact, both of them are prime number. So M and N, 61 and 41, these two are co-prime or relatively prime, or their HCF is 1, right? So now the problem was we have to find M plus N. So clearly you can see that M will be 61, right, in the smallest form. This is the fraction 61 by 41. Now M is 40, M is 61, N is 41. Sum of these two, this will become 102. So that is the correct answer for this problem, right? So as you can see that this was a very interesting problem. We're using this simple result that NCR plus NCR plus 1, this is N plus 1, CR plus 1. We can combine all the terms on left hand side. The important trick was that in order to start that series, these two must be same. We must have N at these two places. But here in first term we had 40C0 and next one was 41C1. So 40C0, this you can write as 41C0. Now sum of first two, 42C1 added with the next one, 43C2 and so on. So left hand side was 61C20. Now compare with this right hand side. Finally M and N, 61 and 41. Their sum will be 102, and therefore that is the correct answer for this problem. If sum of this series 1 square into 15C1 plus 2 square into 15C2 and so on up to 15 square into 15C15, this is 2 raised to m, 3 raised to n, and then 5 raised to k, where m and n and k, these three are natural numbers. So then we have to find the value of m plus n plus k. Now, there are multiple ways of solving such type of problems. Before we attempt this problem, there is one important formula that you should know. NCR, this you can write as n by r and this multiplied by n minus 1 CR minus 1. We'll solve this problem using sigma notation. So for that, we need this formula. NCR is n by r and then n minus 1 CR minus 1. So here let us say this sum on left hand side, this is S. So using sigma notation, you can say that this sum will be summation. In first term, we have 1 square into 15C1. Second term is 2 square into 15C2, right? And so on. So clearly you can see that rth term will be r square and this multiplied by 15CR, and the value of r, this will start from 1, right? For first term we have C1, then we have C2, C3 up to 15. So r will be from 1 to 15, right? This is the sum that we have to calculate. Now here our aim will be to get rid of this variable r. Once I get rid of this r or r square, then we have standard formula for finding this sum, right? I mean sum of first n binomial coefficient nc0 plus nc1 up to ncn. This is 2 raised to n. So that formula we can use. But for that, first we need to remove this r square from here. And for removing r square, we are going to use this result that ncr n by r n minus 1 cr minus 1. That means you can write this sum as r square and this multiplied by 15CR, so that is 15 by R, and this multiplied by 14CR minus 1, right? N by R, and then just decrease both of these by 1. So 15 by R into 14CR minus 1. The range for R is from 1 to 15, right? In final step, we'll consider this one. For all of these, sigma r is least value of r is 1, right? R can take all the values starting from 1 up to 15. Now 1 r you can cancel. 15 is constant that you can take outside, and now we are left with r into 14 CR minus 1. Now the problem is that if I use the formula in next step, in denominator you will get r minus 1, right? This thing you can write as 14 by r minus 1 and then 13C r minus 2, right? But so in denominator you can create r minus 1, but here we have r. So now for that what we can do is we can write this as r minus 1 plus 1 and we'll create two sum from here, right? One will create r minus 1 into this term and the other one will be 1 into this term, so that we can get rid of that variable r, because once I remove that one, then we have a standard formula for that. So this is one again very important step. R minus 1, this is one term, and plus 1, this will be another one. So now we can write this as 15 sigma r minus 1, this multiplied by 14 cr minus 1, and this you can write as 14 by r minus 1, and then 13 cr minus 2, and the other term will be 15, you can keep common, and then we have 1 into this term, so that means sigma 14 cr minus 1, and now you can see this r minus 1 also we can cancel, so ultimately we have 15 into 14 into sigma 13 cr minus 2, and the other term will be 15 into sigma 14 cr minus 1. Now we can write the sum of this series, right? This series will become, remember r is starting from 1 up to 15, right? Here the limit for r, this will start from 1 to 15. Here also the limit for r is from 1 to 15. Now if you take 1, then obviously you will get negative minus 1 here, which is meaningless. So we'll start from 2. At 1 we are getting meaningless term. NCR is defined only when n and r, both of them positive integer or 0, right? It cannot be negative number or fraction. So for this one, although the limit is from 1 to 15, but at 1, we are not getting anything, right? So we'll start from 2. Now, if you substitute 2 here, you will get 13C0, right? If I substitute 3 here, then we'll get 13C1. And this will continue up to 13C13. And I mean, you must be familiar with this result, but again, I'll write this one, that if I have NC0 plus NC1 plus NC2 up to NCN, right? Sum of all binomial coefficients starting from 0 up to n, this is 2 raised to n. So that means here, this first sum, this you can write as 15 into 14, and then this series will start from 13C0 up to 13C13, so that will be 2 raised to 13. And similarly, the second one will be 15 into, and then again, if you take r as 1, then it becomes 14C0. Then at 2, you will get 14C1. So here we have 14C0, 14C1 up to 14C14. So this is nothing but 2 raised to 14. And now you can take 2 raised to, in fact, from here you can take 15 into 2 raised to 13 common, right? In fact, 2 raised to 14 you can take common, 15 we can take common, and then 2 raised to 14. So this becomes 7. And from here you will get 1, right? So finally this will become, this is 8, so 14 plus another 3, that is 2 raised to 17, and then 15 one can write as 3 into 5. So this is the sum that we are getting finally. Now we need to compare this sum with 2 raised to m, 3 raised to n, and 5 raised to k. So clearly you can see that m will be 17, right? Here the value of m, this is 17, n is 1, and k is also 1. So that means this sum will become 19, right? So the correct answer for this problem will be second option. So I mean, these type of problem, they are not difficult. First you need to write using this sigma notation, and then we have to get rid of this r or r square. So first we have written 15 cr as 15 by r, when r will cancel, and in next step you will get r minus 1, right? Because here we have 14 cr minus 1. If we apply the same formula, we'll create r minus 1 here, and that means we need to write r minus 1 plus 1, and now again separate and create two summation. Finally, the sum was 2 raised to 17 into 3 into 5, and therefore m plus n plus k, this will be 19, and that is the correct answer for this problem. If sum of this series 30c1 square plus 2 into 30c2 square and so on up to 30 into 30c30 square, this is alpha into 60 factorial by 30 factorial square, then we have to find the value of alpha. Now this is a problem on series of binomial coefficient, and before we attempt this problem, there is one standard formula that we should know, right? So the formula is that if I have nc0 into mck plus nc1, and this multiplied by mck minus 1, and in this manner it will continue. The last term is, let us say, nck, and this multiplied by mc0. So this is nothing but number of ways of selecting k object from m plus n distinct objects, right? The different cases will be, suppose if I have n objects of one type and m objects of another type. So these left hand side, these are the different cases. Either you will select 0 from the first type and k from the second type, or you will select 1 from the first type and k minus 1 from the second type, and so on. And this is the last case that you will select k from type 1 and 0 from the second type. So this is number of ways of selecting k objects from m plus n distinct object. So this sum should be m plus n c k. Using sigma notation, you can write the same thing as summation n c r, and this multiplied by m c k minus r, where r varies from 0 to k. So this sum, this must be m plus n c k. This is one important property that we are going to use in this particular problem. Here basically, if sum of these two is constant, one is k minus r, other one is r varies from 0 to k. So then, I mean, if you add these two numbers, then you will get k, right? And r is variable here. So then you will just add these two, right? So m plus n, you will get that one here, and add these two, their sum will be k, so that you will get here. So finally, this will become m plus n c k. Now in this problem, we'll need that property. Let us say that this sum is s. So s you can write as summation. First term is 1 into 30 c1 square. Second one is 2 into 30 c square, and so on. So it will be r into 30 cr square of this one. And the limit for r, this is from, for first term we have 1, for last one we have 30. So r is from 1 to 30. Now here we'll first try to get rid of this r, and then we can use that previous property. So this sum will write as r into and 30 cr square. So we'll write that as 30 cr into another 30 cr. So this we can write as 30 cr into another 30 cr. And again r is from 1 to 30. Now in next step you can write this as r into, and 30 cr you can write as 30 by r, and this multiplied by 29 cr minus 1, and the other term will be 30 cr. Right, now r you can cancel from here, and then you will get 30 outside, right? 30 you can keep outside, and then we have summation 29 cr minus 1, and the second term, this we are going to write as 30 c 30 minus r, right? ncr is same as nc n minus r. And now you can see that we can use the previous property. Also the limit for r, this is from 1 to 30, right? This was the limit for r. Now here you can see that sum of these two, if I add these two terms, right? If I add these two terms, so r minus 1 plus 30 minus r, you can get rid of r from here. So the sum of these two, this will become constant. And you can see that if I start with r equals to 0, then this series will start with 29c0, right? 29c0, 29c1, all the way up to 29c29. So it will cover all the terms. That means this series will be number of ways of selecting 30 objects, right? Total 30 we have to, in fact 30 minus 1, so 29, right? If I select 30 minus r from here, then r minus 1 from the other one. So sum of these two, this will be 29. So number of ways of selecting 29 object out of total 59 object, right? You can just use this formula m plus n c k. So add these two, 29 plus 30, this will become 59. And here you will get r minus 1 plus 30 minus r. So this will become 29. Remember, it is important that we must include all the terms of that series, right? So it must start from NC0. Here it is starting from R, but when you take, it is starting from 1, but when you take R as 1, this term will become 0, right? R minus 1, that will become 0. So therefore, this must be 30 into 59C29. And now let us compare with that given expression to find the value of alpha, right? So alpha into, and this thing is 60C30, right? This is the sum given on the right hand side, and here we are getting 30 into 59C29, right? This is 30 into 59C29. Now 60C30, you can clearly see that 60C30, this you can write as 60 by 30 and this multiplied by 59C29. And on right hand side, you have 30 into this term, right? 59C29. So these two you can cancel and then alpha will become 30. I mean, this is 2. So 30 by 2, that will be 15, right? So this should be value of alpha. And therefore, the correct answer for this problem will be 15. So this was another important problem where first we had to be familiar with this formula that NCK plus MCK minus NCR plus MCK minus R. If it includes all the term, then it will become M plus N C K. So first we got rid of this R right here. This was the series that we had to calculate. So 30 CR, we can write 30 by R you can cancel. And then 30 CR, this you can write as 30 C, 30 minus R. And now for this one, we have standard formula. So finally, when you compare with the given sum, then you will get alpha as 15. And therefore, that is the correct answer for this problem. If the sum of this series, we have some function of r multiplied by 11cr plus 1, r from 0 to 10. If this is alpha raised to 11 minus 11 raised to 11, and this divided by 10 raised to 10, then we have to find the value of alpha. So basically, we need to find the sum of this series, and then by comparing with the right hand side, we have to find what should be the value of alpha. Now, before we attempt this problem, there is one important formula that we should know. The formula is basically that if I have sigma NCR and this multiplied by a raised to r is from 0 to n, right? So this is nothing but binomial expansion of 1 plus a raised to n. I mean, clearly you can see that if you take r as 0, then you will get 1, which is the first term. If you take r as 1, then you will get nc1a, right? The left hand side, I mean, this will be 1 plus nc1a, nc2a square, nc3a cube, and so on, up to ncn a raised to n. So that is binomial expansion of 1 plus a raised to n. Now, there are a few PYQ where using the simple result, you can get the sum of this series. Notice the important thing here is that if I have NCR, the exponent of A must be R, right? Then only you can combine these two, and also R must be from 0 to N. If R is starting from 1 or from 2, then we have to account for those terms also, right? So here, let us say that this sum is S. So S you can write as sigma R from 0 to 10. In last step, we'll talk about this limit. First, let us simplify this function. So here if I separate these two, that means one I'll create 10 raised to r plus 1 by 10 raised to r, and the other one minus 1 by 10 raised to r. So 10 raised to r plus 1 divided by 10 raised to r, that will be nothing but 10 into, and then this other term is 11cr plus 1. So this is one sum, and then minus sigma 11cr plus 1, and the other term will be 1 by 10 raised to r. Now, for first one, we'll use a standard formula. And in this second one, you can see that in order to apply this formula, here we have 11cr plus 1, and this one is 1 by 10 raised to r. Now, our aim will be to create, we must have same number here and here, right? If this is 11cr plus 1, we must have 1 by 10 raised to r. So, for that, we can multiply and divide by 10. If we divide by 10, it becomes r plus 1. And if we multiply by 10, that we can write in numerator. So this is one important step here, because if I have to create plus 1 and then into 10, so now this becomes, these two numbers are same. Here we have r plus 1 and here also we have r plus 1. And now we can use that standard formula. Also limit for r, this is from 0 to 10. And here also limit for r, this is from 0 to 10. So this will become, first term will be 10 into, if you take r as 0, this will become 11c1, right? That r equals to 0 will get 11c1, then 11c2, and so on. Last term will be 11c, and then if we substitute 10 here, we'll get 11. So this is the first sum, minus the second one will be, now here again you can notice that if I start with r equals to 0, then we'll get 11c1, 1 by 10 raised to In fact, 10 we can keep common, right? 10 we can separate, and then this sum becomes, if I uh, substitute r as 0, then this will start from 11c1, right? So the first term 1 in the expansion of this one, the first term will be nc0 a raised to 0. So that term is missing. After that, you will get all the terms 11c1, 11c2, 1 by 10 square, 11c3, 1 by 10 cube, and so on, all the way up to 11c11, right? At 10, you will get 11. So 11c11, 1 by 10 raised to 11. So this sum, using the previous formula, you can write this as 1 plus, in place of a, we have 1 by 10. So 1 plus 1 by 10, this raised to 11, right? The last one will be 1 by 10 raised to 11, and minus 1. Minus 1 because we are not getting 11c0 term, right? This series is starting from 11c1. So therefore, we have to do minus 1. Now, this side will be 10 into 2 raised to 11 minus 1. Again, a standard formula, sum of all these, I mean nc0 plus nc1 up to ncn, this is 2 raised to n. Again, this is starting from 1, right? So 11c0 we have to subtract from here, and then minus 10 into, and this will become 11 by 10 raised to 11 minus 1. Now this minus 1 you can cancel, right? If you take 10 common from all of these, so then you can get rid of that minus 1. So basically this is 10 into 2 raised to 11 minus, and if you separate these two, then you have 11 raised to 11, and this divided by, you can get rid of 10 from here, so 10 raised to 10. And this minus 10 and minus 10 from here, those two you can cancel, right? Minus 10 plus 10, so that will cancel. And now we can take 10 raised to 10 as LCM. You can see that if I take 10 raised to 10, 1 by 10 raised to 10 common from all of these, then this will become 10 raised to 11, and 10 into 2, that will become 20 raised to 11 minus 11 raised to 11. So this is what we are getting. Now let us compare with the given expression. This sum, 1 by 10 raised to 10, and then we have alpha raised to 11, 11 raised to 11. In place of alpha, clearly you can see that we are getting 20 raised to 11. So that means the value of alpha, this must be 20, right? So the correct answer for this problem will be second option. So this was a problem, I mean, not difficult problem. First, we have to use this formula. NCR a raised to r, that is 1 plus a raised to n. R from, this is important, r must be from 0 to n, and also these two must be same. So, I mean, we created two sum here, and in order to create same number r plus 1, we had to multiply and divide by 10. And now we had a standard formula for first one as well as second one. After simplification, finally we got this sum. So if you compare with the given result, given expression, then alpha is 20, and therefore correct answer for this problem is second option. If the sum of this series 11c 2r plus 1 and this divided by 2r plus 2 are from 0 to 5, this is m by n, and it is given that greatest common divisor or HCF of mn is 1. So the meaning of this line will be that there is no common factor between m and n, and that fraction m by n, this is in its smallest form, right? Because I mean we have to find the value of m minus n. Now m and n, those two will have unique value only when these two, there is no common factor between m and n, right? So first we have to find sum of this series, and from there we have to find the value of m and n. Also, if there is any common factor between these two, then we have to cancel that one. Now, the general method of solving these type of problems where you have variable in denominator, right? 2r plus 1 or any function of r in denominator is to use integration method. However, there is another much easier method using properties of binomial coefficients. So here we are going to use one important property, that if I have NCR, then this you can write as n by r, and this multiplied by n minus 1 cr minus 1. Okay, this is one of the most basic property of NCR, the binomial coefficient. So here what we'll do is that let us say this sum is S. So S is basically, we have r from 0 to 5, and then in denominator we have 2r plus 2. Right here we have 2r plus 2 in denominator. And then this term is 11c 2r plus 1. Now, if you see this previous property, I mean, we are going to use the property from right to left. That means this right hand side will convert in this form NCR, and then we can use standard result. So basically, we want to combine this 2r plus 1 in denominator with this 11c 2r plus 2, and we can create single NCR from here. So for that, you can see that if I have r minus 1, this must be r. And if I have n minus 1 in numerator, we must have n. Right? In numerator, right now we have 11. So we need a number 1 bigger than this one in numerator. So I mean, number will be 12. So basically multiply and divide by 12. And now you can see that 12 by 2r plus 2 and this multiplied by 11c 2r plus 2. This will be nothing but 12c 2r plus 2. Right? Using this previous property, I mean, we can combine these two terms, and then this one we can write as 12c 2r plus 2, and r from 0 to 5, 1 by 12 we can keep outside. And now this is a very simple problem. 1 by 12, in place of r, if we substitute 0, then we'll get 12c2. If I substitute r as 1, then we'll get 12c4. In this manner, it will continue. And the last term that we are going to get is 12c. In place of r, if we have 5, then we'll get 12c12. Now, this is sum of even binomial coefficient, right? We have 2, then we have 4, then 6, up to 12. But you can notice that 0 is 12c0 is missing from here, right? If I had 12c0 also, then the answer will be 2 raised to n minus 1. Right? NC0 plus NC2 plus NC4 all the way up to last term, that is 2 raised to n minus 1. So here that 12C0 is not there. So therefore we'll write this as 2 raised to 11 minus 12C0. And now this will become 1 by 12. 2 raised to 11, this will be 2048. Right? 2 raised to 10 is 1024. So twice of that 2048, and then minus 1. 12C0 is 1. So that means we have 2047. Right, so this is the sum that we are getting. Now we need to check, I mean, this line means that there is no common factor between these two numbers. Right, finally we are getting this one, 2047, and this divided by 12. This is the sum that we are getting. So clearly this number is not multiple of 2, and 7 plus 2, 9 plus 4, 13. So not multiple of 3. That means there is no common factor between these two numbers. Right, this number is, this fraction is in its smallest form. We need m minus n. So clearly the value of m will be 2047. N is 12. So m minus n, that will be difference of these two. So that means we have 2035. So that should be the correct answer for this problem. Right. So this was a problem where using this property of NCR, I mean, this was the most important step here. Multiply and divide by 12. And then you can combine these two, and you can write this as 12c 2r plus 2. And after that, we have sum of even binomial coefficient except 12c0. So we got 2 raised to 11 minus 12c0. Finally, your answer will be 2047 minus 12, that is 2035.